Hey guys, welcome back. Now let's have a look over a new sensor from the temperature family MCP9805, and it's another sensor that will be MCP9805. And to gain more knowledge about this sensor, let's have a look over the website that will be controleverything.com, and here we have to search for this sensor as you know on my screen, and it will be MCP9805. As you see, it's a memory module digital temperature sensor, and the accuracy will be plus minus 1 degree Celsius. And as you can see, these are some more features which you are able to see, and also you can add to cart. You can purchase the sensor right from here. Also, I will be interfacing the memory module digital temperature sensor MCP9805 with a BeagleBone Black and using a C code language. And let's go to resource tab, and we can have the C code sample onto your screen. You can download the C code sample as a zip file right from here, and also you can get the code from github.com, and the concerned repository there will be control everything community. Now let's have a look over the hardware connections we need to put up together, and let's see what we got here. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen, and this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Next, we need our sensor that will be memory module digital temperature sensor MCP9805, and this here is a connecting cable. Now make sure the connection among the cable and the sensor and the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the I2C shield. Now we are done with all the connections we need. Let's move ahead and see our code. Now let's look over the interfacing section, and here we have to log into github.com first of all, and here we have to search on for the repository that will be control everything community. And for further moving, and this here is our sensor, that is the MCP9805, and this comes the C code. But let's have a look over the instructions part first. As you notice, we have to set up our BeagleBone Black, and the steps to set up this device is on BeagleBone.org. Let's open up this link, and you can have your own viewpoints regarding this installation. We have to install some applications, drivers, and you will done. And after that, you need to download the code onto the BeagleBone Black, and this command will compile, and this will run the C code carefully. Now get back to the C code. As you notice onto my screen, it's a .c extension file, and the first thing you see into the code, it's the we have included some of the libraries, and in the void main function we have created an I2C bus, and we will check whether the I2C bus is open or closed, or whether the I2C device is connected onto the right address. That will be 0x18. Now coming to the writing section part, first of all we need to select configuration register 0x01, and we are going to send a command for continuous conversion mode power up, that will be 0x00 0x00. It's a 16-bit command we are going to send it, and as you know, this is the writing part. Now this here is to select resolution register, that will be 0x08, and we are going to set a resolution for this sensor that will be plus 0.0625 per degree Celsius, that will be 0x03, and which you are clearly able to see on my screen. And after that we have a sleep function for 1 second delay. In the reading section, first of all we need to read the data back from the sensor. We are reading 2 bytes of data from register 0x05, and after that we have the conversion of the data using some of the formulas we have derived from the data sheet of MCP9805. At the very end of our code, we have the output data to be displayed onto the screen, which means we have the temperature in Celsius and Fahrenheit. So this is how the sensor looks like. Now let's have a look over how it works. Now let's have a look over the practicality of this sensor and the code, and for that we need to copy the entire code as you can see on my screen. And after that we need to connect it to the BeagleBone Black, and here we have to create a new file as you can see on my screen. It's a .c file, and here we have to paste it, and after that we need to save it. Now this is the command for the compilation as you can see on my screen, and here this is the full command. Compilation is done successfully. Now for the running of this code, let me tell you, this is the command, and when I run it we have the temperature in Celsius and Fahrenheit. Similarly, when I again run it, there is a very slight change or no change, which means there is nothing which is affecting the temperature. But right now when I place my finger over the sensor and run the command, we can have a significant change in temperature for both scales, Celsius and Fahrenheit. And when I again run the command, the change is reflected onto the screen. So this is how the sensor works. Now let's have a look over the applications and some of the benefits. The MCP9805 comes with user-programmable registers that provide flexibility for DIMM temperature sensing applications. The registers allow user-selectable settings such as shutdown or low power modes and the specification of temperature, event and critical output boundaries. This sensor has a 2-wire industry standard SM bus and standard mode I2C compatible and serial interface protocol, allowing up to 8 sensors to be controlled in a single serial bus. These features make the MCP9805 ideal for sophisticated multi-zone temperature monitoring applications such as dual inline memory module DIMM, personal computers and servers, general purpose temperature sensor, hard disk drives and other PC peripherals. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site you can download the code as zip file. Also you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.